The universe is 13.8 billion years old, and our galaxy, the Milky Way, contains at least 100 billion stars. Current data from the Kepler Space Telescope suggests that 1 in 5 of those stars has an Earth-sized planet in the habitable zone, where liquid water can exist. That means there are roughly 20 billion Earth-like worlds in our galaxy alone. If even 0.1% of those planets developed life, there should be 20 million civilizations in our neighborhood. The Milky Way is about 100,000 light-years across. Even with current rocket technology, a civilization could colonize the entire galaxy in about 10 million to 50 million years. In cosmic terms, that is a weekend. So the question physicist Enrico Fermi asked in 1950 remains the most important mystery in science. Where is everybody? One of the most evidence-based solutions to this paradox is the Great Filter. This theory suggests that in the journey from basic chemistry to a spacefaring civilization, there is a barrier that is almost impossible to cross. Is it behind us? If the filter is the transition from simple cells to complex eukaryotic cells, we might be the only ones who made it. It took 2 billion years for life on Earth to make that jump, suggesting it's a freak occurrence. Is it ahead of us? This is the terrifying version. It suggests that almost all civilizations eventually reach a point of technological maturity where they accidentally destroy themselves. Potential filters include rogue artificial general intelligence, gray goo scenarios where nanobots consume the planet, or large-scale nuclear conflict. If we find fossils of complex life on Mars, it would be the worst news in history. It would mean the Great Filter is likely ahead of us and we are headed for a dead end. To find aliens, we look for energy signatures. In 1964, Nikolai Kardashev created a scale to measure a civilization's level of advancement based on its energy consumption. Type 1 can use all the energy available on its home planet. Humans are currently at about 0.73. Type 2 can harness the total energy output of its parent star. This is usually visualized as a Dyson sphere, a massive structure surrounding the star. Type 3 can control the energy of its entire galaxy. A Type A3 civilization should be visible across millions of light years due to the heat waste generated by its machines. However, a 2015 study of 100,000 nearby galaxies found exactly 0 signatures of Type 3 civilizations. This implies that either the jump to a Type 3 is physically impossible, or civilizations don't survive long enough to reach it. If the math says they should be there, but we hear nothing, maybe they are being quiet on purpose. The Dark Forest Theory. Taken from Liu Cixin's sci-fi, this suggests the universe is like a dark forest filled with armed hunters. Because of the chain of suspicion, the fear that another civilization might be hostile, the only logical move is to stay hidden. If you shout, you get eliminated by someone who doesn't want to take the risk of you being a threat. The Zoo Hypothesis. This theory argues that advanced aliens are aware of us, but have placed Earth under a quarantine. They treat us like a nature preserve, or a primitive tribe in the Amazon, watching us from a distance and waiting for us to reach a certain level of ethical or technological development before making contact. This would explain why we see UAPs, unidentified aerial phenomena, but no official communication. Maybe the reason we don't see starships is that space travel is actually a bad idea. Transcension. Instead of expanding outward into a cold, empty universe, advanced life might move inward. Using computronium, a theoretical matter that can process information, a civilization could live in a hyperdense simulation. By shrinking their technology to the nanoscopic level and living near black holes for energy, they could process more experiences in a second than a spacefaring race could in a billion years. The Rare Earth Hypothesis. We might be underestimating how lucky we are. Our moon is unusually large, which stabilizes Earth's tilt and prevents chaotic climate shifts. We have a massive gas giant, Jupiter, acting as a gravitational shield against asteroids. We are in a galactic habitable zone, far enough from the radiation of the galactic center, but close enough to have heavy elements from old supernovae. If these factors are all required, we might literally be the first and only intelligence in the Milky Way. As of 2026, we have scanned millions of radio frequencies galaxies and analyzed thousands of exoplanets. Yet the "wow" signal of 1977 remains our only and highly debated hint of something else. If we are truly alone, the stakes for human survival are infinite. We are the only eyes the universe has to see itself. But if we aren't alone, the silence suggests we are part of a game where the rules are much more dangerous than we realize. Whether we are the first, the last, or just the quietest, the Fermi Paradox proves that our existence is either a miracle or a target.